All right, everyone, welcome back. By now, you should have finished the activity before this video, which was the warm up, which is for our new unit, Ocean, Atmosphere, and Climate. Now, I want to introduce to you our unit question. So, this is the question that we are trying to answer. We want to be able to answer this question by the end of the unit and have good evidence, right? So, we talk about clever a lot, claim, which is the answer to the question. We're going to have to answer it, so we're going to have a claim. Evidence, that means that those are pieces of information that basically back up our answer, right? It's good to have evidence, and then reasoning. So we need to be able to explain why our evidence is important and how it supports our answer. But to get back to that, let's read our unit question. So, what determines the air temperature of a location on Earth? So, think of any location on Earth. Think of Long Beach, California. Think of Dallas, Texas. Think of Miami, Florida. Think of Beijing, China, or Tokyo, Japan, or Paris, France. These are all different locations on Earth. What determines the air temperature? So, how hot or how cold it's going to be? What determines that any place's air temperature? So, that's what we're going to be working to try to figure out. I mean, you can probably think of a place on Earth that's usually very warm or a place that's usually very cold. Have you ever thought about what determines the air temperature of a place? This is what we will focus on in the oceans, atmosphere, and unit climate. Now I'm going to take you to Amplify because we're going to be watching a video on Amplify that's only available on the teacher side, okay? So before I show you the video, I want to just give you a little intro. So in this video, you will meet scientists who are researching air temperatures in different places and what it is that can make the air temperature change. Okay, so we're going to be watching about some different scientists, right? Because there's scientists that study the weather. That's what they do. They study air temperatures. All right, let's see what this is all about.
I'm Marty Hurling. I'm a climate scientist at the National Oceanic and Atmospheric Administration in Boulder, Colorado, and I study El Nino. El Nino has some puzzling aspects to it. It lasts 12 months. It returns maybe every 2 to 7 years. When El Nino happens, the ocean temperatures change and the air temperatures change over the whole planet. And they can change by, almost 2/10 of degrees Celsius, almost a half degree Fahrenheit. And that kind of change, you might say, well, that's not very big, but actually it is big, and we can see it happening. El Nino is something that causes radical changes. Some places get way too much rain and they get flooded out, and it can be damages to homes. Some areas that normally get rain, suddenly the rain shut down. They get fires, drought, their crops don't grow, a lot of problems. We had this big El Nino this past year. It was so big that we decided within NOAA to go out and hunt it down, take new measurements to see how it ticked. We combined planes, ships, we go to remote islands, we launch balloons.
My name is Dan Wolf. I'm a research meteorologist, and I was part of the El Nino Rapid Response Project. The ship traveled from Hawaii to the equator, collecting ocean temperature and also releasing weather balloons as we went. The data are transmitted real time back to a computer on the ship where we can watch it. Then we can send it back to Boulder where modelers use it to help better understand the weather and El Nino.
I'm Dr. Leslie Harton. I'm a research meteorologist, and this spring I spent 5 weeks on a small island called Christmas Island in the equatorial Pacific, and we went there to launch weather balloons. Christmas Island is in a part of the world where there are almost no regular weather observations, and it's also right at the heart of the El Nino that was happening this year. We launched our weather balloons at 1:15 in the morning and 1:15 in the afternoon. An instrument package like this is attached to the weather balloon. And as the balloon goes up, We measure temperature and humidity and winds and pressure. Our data give us a really unique picture of how the atmosphere is behaving in that region when there is a strong El Nino.
Hey, Honolulu, this is Boulder, and we're ready to go through the briefing this morning. So every day, the aircraft would have to fly out from Hawaii to the equator to get some idea of what El Nino was doing. Kelly, do you expect both radars on board to be active to help you through that convection?
Yeah, thanks, Marty. We should have both radars working on today's flight, so that will be a big help.
I'm Dr. Kelly Mahoney, and I served as a mission scientist for the El Nino Rapid Response Project aboard the NOAA research aircraft. We had manned aircraft with the whole flight crew aboard it, and then an unmanned aircraft. And the mission of both of these aircraft was to go out and get close enough to thunderstorms that we could either circle around them or get close enough to feel some of the winds that were coming out of them. As we got close to the thunderstorms, our job was to drop instrument packets out of the airplane to measure the temperature, moisture, and wind speeds right around the thunderstorms. The data that we collected is truly unique and very useful and valuable to our weather and climate models.
So I really like doing this science because we're trying to understand the way El Nino works, the ocean and the atmosphere, how they link. It affects weather patterns. Many people's lives are really affected by this. And that's really why the data are so important. It helps us make better forecasts and helps people's lives.
Wow. I just want to stop right there and tell you guys some of my kind of initial thoughts from that video. I think how it is so interesting that they use these balloons that they use a scientific tool attached to it that records all this information, and how that information is then sent back to the boat or to a computer that it's not near. I think that's unbelievable, and how it's so true. Weather affects all of our lives, right? If it's hot, you're going to wear a t-shirt, not a heavy jacket. If it's raining, you're going to wear long sleeves, you're going to wear shoes, you're going to wear pants. You're not going to wear flip-flops and shorts when it's raining. That just doesn't make sense, right? So understanding what the weather is going to be is a very important job, and that is a job of a scientist, and we are going to kind of get into being climate scientists. Okay, next. We are now in activity 2, and before you go back to Amplify, I'm going to talk through a couple things, okay? So hold on. So we're going to be focusing on Christchurch during El Nino. So we're going to be focusing on this place in New Zealand. And what we're going to be doing is students are introduced to their roles as climate scientists, studying why Christchurch, New Zealand has a different air temperature during El Nino years. Now, I know many of you are Spanish speakers, so El Nino, right? Translate that for me, okay? Now think about El Nino years. Very interesting why they're naming this type of air temperature change El Nino. Before we move forward, I want us to focus on this word climate. Climate is a vocabulary word that we will be using and hearing multiple times throughout this chapter, multiple times throughout this unit. I'm going to read the definition and point to it as I follow along. So, general weather patterns over a long period of time. So, it's not day to day, it is over a longer period of time. So we're going to be focusing on that. Before we go to the next one, I want to focus on this right here. Climate, our role as climate scientists. Right over here. The scientist we heard at the beginning of the video is a climate scientist. Climate scientists, or climatologists, as they are sometimes called, study weather patterns over time. For example, a climate scientist would investigate a location's average temperature over a long time, not the temperature on a particular day. Climate scientists expect a particular location's climate to stay the same. When they make observations that are out of the ordinary, so that means when they make observations that are different for a place's climate, like a particularly high or low temperature over a period of time, for that place, they carefully consider what the data might mean. And this word's going to be available in our glossary if we need it, but climate is the weather patterns over a longer period of time. I'm going to click next to our next part. Okay, now I want us to look at, so this is a message from the director of New Zealand Farm Council, and I'm going to read this aloud. So it's to us from Kiri Parata. It says, I am a director of the New Zealand Farm Council. Our organization represents farmers in the area surrounding Christchurch. Every few years, we notice climate changes that affect the crops. During El Nino years, the air temperature is much cooler than usual, and we would like to learn why. So the farmers are better prepared for these temperature changes. We are asking you, our student climatologist, to conduct some research on what determines Christchurch's air temperature, especially why it decreases during El Nino. Looking forward to working with you and hearing what you find out. Kiri. Okay, well, we have some work that we need to do. So we're going to be doing some investigating, and I want you to also be thinking about the weather and you that is going on now, Go outside, make an observation about the weather. Is it hot? Is it cold? Is it foggy, cloudy, sunny, rainy? Tell me, describe it, think about it. All right. Our next activity would have been something that you would have done with a partner, and unfortunately, you're not with a partner, okay? But what you're going to be doing is you're going to be looking at this map right here. Okay, so you're looking at this map and you're looking at Christ Church's location. So this location is in New Zealand, and New Zealand is a country located in the southwestern Pacific, near Australia. So this is Australia. This is New Zealand in the southwestern Pacific. There are two main islands, and Christchurch is in the starred location on the South Island. So there's a couple islands, one and then two. So Christchurch is on the second island. So this is the location that we're thinking about. We are over here, okay, in North America, but we're going to be looking at this location here, Christchurch, New Zealand. When scientists, I'm gonna pause right